Work, we're going to be discussing the version of work that is dealt with in physics. It's not the version of work that you talk about in daily life. It's not, I'm going to go to work. I'm going to do my homework. It's not, I'm doing classwork. It is, in physics, it has to deal with a force applied over a distance. So when you have a force being applied over a distance, then you have work. So we know force is work is equal to some force times distances applied. Okay? The units for work deal with units of force, a Newton. So we have a Newton. We also have a unit for D. We call D meters. So the unit for work is a Newton meter, which is also the same thing as a joule. Oh, we've been talking about joule. Joules are energy. So work is a form of energy. Now, if I'm standing here and I'm holding a flagpole, okay, and I'm standing here and not doing anything else, the flag is not moving. I'm just standing there. No work is being done. So, when the Flag Corps says they did some hard work and practice, and all they did was stand there holding the flag, they did no work in the perspective of physics. However, if the flag is on the ground and you pick it up and you move it, and I've drawn a great big huge hand, and you pick it up and you move it to where now you're standing and holding it, you've done work. Okay? And the amount of work you've done is work against gravity. Because what's gravity doing? Gravity is pulling down. So you're working against gravity. So it tends to be a negative, if you want to look at it that way. Because you're going against, you're pushing against it. So it would be equal to the force you applied times the distance it moved. So for example, say you move that flag from here on the ground and you move it to up here where you're holding it, and that distance is 2 meters. And the flag, let's say, has a weight of 2 newtons. So the force due to gravity is 2 newtons, which is the weight of the flag. So how much work did you have to do to overcome gravity? So that would be equal to work times the force times the distance it's moved. So it's 2 times 2, which is 4 joules of work. Or you could say 4 Newton meters of work. Both are correct. They're the same thing. So it took 4 joules of work to move that flag. Now, once you get that flag there and you're holding it, you're doing no work whatsoever. That flag has to move. So, now we have, let's say, a box. And we have a box that has a mass of 10 kilograms. And you're pushing the box. Don't you love my pictures? And you're pushing the box along a table. It's a low table. And you're pushing with a force of 5 newtons. And you move that box from one end of the table to the other, which is 2 meters. So, how much work did you do on the box? So the work on the box, we know, is force times distance. Well, our distance is 2 meters. Our force is 5 newtons. That mass, excess information, we don't need. So we need force, which is 5, times 2. So that means it is 10 joules of work done on the box by you. So we've done work moving a box across the table, work moving a flag up from the ground. What if we're holding something and we're holding it and the ground is 2 meters away and we set it down on the ground? Oh, now we're doing work with gravity. So it's going to be a positive. We have force, let's say, is 2 newtons. So work with gravity is still force times distance, which would be 2 times 2, or 4 joules. What if, let's say, our box that we're holding and our 2 meters that we've got to set it down, but we don't know force, but we know mass, and we're going to say mass is 5 kilo. So we have a box that's 5 kilograms, and we are going to be setting it down on the floor. So that means we're working with gravity. We know gravity is 10 meters per second squared. What else do we know? We also know force, in this case, is mass times acceleration. Well, we're doing mass times acceleration due to gravity. So that's the same thing as mass times gravity, which is 5 times 10, or 50 newtons. That's our force. That's also known as weight. Weight is force due to gravity on an object. It's how much something weighs. So we know weight. So now we know work. Work is equal to force times distance. So we have our force, which is 50. It's moving a distance of 2 meters. So that means we do 100 joules of work on that box. Now what about something moving and It's moving at a constant velocity. If it's got a constant velocity, does it have acceleration? That's what you're wanting, because force is equal to mass times acceleration. If it has an acceleration, it has a force. If it doesn't have an acceleration, it doesn't have a force. Well, the magic words here, constant velocity. So that means velocity is not changing. So velocity is not changing. There's no acceleration. There's no force. So there is no work done.